Hello, everyone. Welcome and thank you for attending today's IBM Community Webcast. My name is Anna, and I'll be moderating today's webcast. Our topic for today is Into Data Science, Understanding Decision Trees. All phone lines are currently in listen-only mode. Please note that audio is played through your computer or device. There is not a dial-in number. There will be a question and answer session towards the end of the presentation. You may ask a question at any time during the presentation by typing your question into the Q&A widget located on your screen, and we'll get to your question toward the end of the webinar. Tomorrow, we will have a recording of today's presentation available on the IBM Community website. To access the presentation, please see the resources list in the top left corner. You will receive a follow-up email with a link to the archives as well. Now I'd like to introduce our speaker for today. We have joining us Jack Roy, IBM Executive IT Specialist, Digital Technical Engagement, Watson Data, and AI. Thank you, Jack, for joining us today. The floor is now yours.
Thank you. So welcome, everybody. Welcome for attending this webcast. There's a lot I could have covered. I could have talked about different algorithms, naive Bayes k-means, alternating least square, and even get into neural network. But I believe that the people need to get to the basics and start with something that can be easily understood to get into data science. It really drives me crazy to think that there are so many people that have years and years of experience in information management that feel that they are obsolete. And so the idea here is really to try to get people to understand what this is about so they can participate in teams to introduce machine learning, data science, deep learning, etc., within their organization. By the way, also you see here I say bite-sized data science, and at the bottom you have a URL. So for people that want to learn more about data science in general, I have a YouTube channel that provides a lot of short videos that would help you get up to speed with data science and machine learning, etc. I have something like 23 videos posted at the moment, and I keep adding videos every week. And so this is a little bit more in depth than what I do in my channel, and hopefully I'll be able to do regular webcasts about this subject. So before we dive into decision trees, let's take a quick look about what machine learning is about. And so when we talk about machine learning, really the core of machine learning is to be able to predict, classify, and cluster. And so when you think about machine learning, you have to kind of think into these terms. How can you find patterns, really? How can the machine learning find patterns within your data to get to these predictions and be able to classify customers, for example, to decide what type of products would be attractive to them. And the clustering also can give you ideas of where the action is in different situations. And so when I got into looking at decision trees several years ago, my first question was, why is that machine learning? So first, let's take a quick look at what does that mean what does machine learning mean? And you see a definition here, a field of study that gives computers the ability to learn without being explicitly programmed. And so that was from 1959. And so these ideas have been around for a long time. And so with that in mind, let's get into what decision trees are about. Just as a quick preview about this, there are multiple types of decision trees, and we'll explore that a little bit further in the presentation. But for now, let's get what is a decision tree. So for people that have been doing programming, it's pretty obvious that a decision tree is really making decisions on your data and saying, if this, then look at a different aspect of it, else, etc. So you see, this really is in a form of a tree. So the first question is, why is that machine learning? And the idea behind that is the fact that it can look at your data and figure out what what needs to be taken into consideration to make a decision in one way or another to get to a point where you have a high level of confidence on the decision you make. And the decision can be either a binary decision, and we'll see an example in a minute, related to churn analysis. So it's either a customer is likely to churn or is unlikely to churn. Or it can be multiple choices in terms of you could have, let's say, 10 different selections that you decide where the specific customer ends up with. And decision trees can go as far as looking for continuous values. So let's get through an example. And so the first example, the example I have here, the data is a telco record, and you see here I highlighted the churn column. It's true or false, and so what that is really the data that is pre-qualified. Basically, we have the answer already, so we can feed that to the algorithm to decide what will be the answer at the end. And because of that, the algorithm is able to find the patterns that will lead it to the most likely answer being either the customer will churn or not. The other thing I'd like you to notice here is that there are multiple other columns that are actually character columns. When we talk about machine learning, we always talk about numerical values. So what that means is we need to be able to convert these numerical values to these character values to numerical values. So it's relatively simple to think about gender, feminine, masculine, and so there's two possible values. The status, it's single, married, or divorced, 3 different values. Co-ownerships, again, 2 values. Payment method could be multiple values, etc. And so basically, the idea is to convert these values to a set of numbers, and basically if you look at how many choices you have, you can then decide how many numbers that you need, and so that's one way to convert it into numbers. Okay, so instead of staying in the theory part, let's go through a demo here. What I'm using here is Watson Studio in the cloud, and I'm using a feature of Watson Studio that's called a modular flow. The reason I did that is because I did not want to just show a bunch of code where it's easy to get lost in the code. There's too many details. So with that at a high level, with the modular flow, I'm able to see what are the different transformations that need to be done. In addition to that, the product I'm using under the cover of modular flow is SPSS. And again, the reason I picked that is because I'll be able to see more details. So in the modular flow, basically, I have multiple operators. So I have a data asset that I can import. I have a field operations, and you see here the type. And that's the operator here that will take the raw data and convert these columns that are a character into numerical values. And then I feed it into another algorithm in the modeling part that is the C5 algorithm. So that's what it is. And you see in the diagram that kind of tells you that C5 is a tree, decision tree. And I'll talk about what C5 is a little bit later after this quick demo. And you see there's a bunch of other algorithms. One decision I could have made is simply use an auto-classifier that would have then decided between multiple algorithms to see what's the best solution, the best modeling tool to use. So I ended up creating a model, and that's what I have here, and I could then publish that and be able to score records that don't have that answer in it and say, well, according to the values in the record, I suspect that this customer will churn, for example. And so the reason why this is, again, machine learning is because the algorithm under the cover for the decision tree makes the decision of which values to look at, which one provides the best discrimination between what's available to make the decision. So let's take a quick look at the model that gets generated. So what I have here is the model information. And again, it's a binary decision tree because, again, I'm talking about churn. It's yes or no. And the algorithm is C5. One of the reasons why I picked the SPSS product is because it gives me more information about how the decision was made. And so you see here that looking at all the different columns that I had in my record, it went through and decided that status was actually the one that was the most significant. It's the importance 0.263, but that still tells you that you start with status, estimated income, number of children, payment method, usage, etc. And so all these decisions, you could, in one way, you could imagine making these decisions manually and going through the record, but you can see that doing it manually would easily overwhelm anybody as soon as you have a dozen columns, and where the decision tree is able to go through all these different records, look at the patterns, and decide which columns are really significant, and go all the way down to saying that when we look at that, gender is actually not important at all. And so that's the reason why this is a machine learning algorithm, because it's able to look at your data and look at the patterns and decide what's important. And so the other information I can get here is the top decision rules. And you see that the decisions are not just is status S or single or married or divorced. It looks at multiple values. And that's part of the underlying algorithm that makes these decisions. And basically what it says here is that this rule is the top rule that really is able to better discriminate, to decide to get to a truth value with a very high level of confidence. Another way to look at the diagram here is in the form of a tree, and so again that's pretty obvious. Why it's called a decision tree, and you see all the decisions that are being made, and you could even put some of the rules on top of that. So hopefully with this quick demo, looking at the predictors and top decision rules, that gives you an idea why it's called a decision tree, how the decisions are made. So it's pretty transparent at the end that you're able to, if you're, let's say, running a bank and you need to decide do you give a loan to someone or not, you can easily then explain why you made that decision, where some other algorithms are more opaque and it's more difficult to see the result. So with that being said, let's go back to the presentation and go to talk more about decision trees. Here I have this statement here: all decision trees are not created equal. And the reason I'm saying this is because at first blush you may say, oh well, I'm using a decision tree, and that's the end of it. You kind of have to take a look a little further down to figure out what you're using there. Depending on your environment, you may not care too much how efficient the algorithm under the cover is, but it gets to a point where it can become important. And depending on the product you're using, you could be using Spark, you could be using sklearn, and so many other libraries. Just by digging a little further on what's under the cover, that can give you an idea of which implementation you may prefer to use. And so, from what I could find, the first really significant implementation that was provided was called ID3 from somebody from Australia, I believe, called Quinlan, back in 1979. And so that algorithm, you may see it available in different places, and that's an older type algorithm. One thing is, again, it was a first implementation. It doesn't necessarily guarantee an optimal solution. So, and it doesn't necessarily produce the smallest possible decision tree. So it's not perfect, but it's still a good approach. then that same person went through multiple iterations. There was a C4.0, and you kind of see where I'm going with that. But the C5 came out, and it was actually ranked number one in the top 10 algorithms in data mining in a preeminent paper, and so that made it very, very popular. So there's a lot of chances that you'll see C4.5 implemented in many of the available decision trees. And some of the improvements compared to the ID3 is that it's able to handle continuous values in addition to discrete values. And it has other attributes where, for example, the pruning of the tree after the creation makes it more efficient at the end. So these algorithms, ID3 and C4.0, C4.5, are open source algorithms. And so once again, the C4.5, you'll see it pretty commonly in many places. Then there was another one that came out, and again, I put at 2007. That's what I could figure out. I may be slightly wrong, but that seems to be the date. But this one is actually a commercial implementation. And that ties back into my little demo there, where that's what I've been using in terms of the decision tree. And the C5.0 algorithm is significantly faster than the C4.5. The claim is several orders of magnitude. It uses memory more efficiently, and the decision tree result is a lot considerably smaller. So that's pretty important. A couple of one more thing. There's multiple other things, but one more thing I'd like to mention is the support for boosting to improve the accuracy of the tree. And I'll talk about that in just a minute when I move on to another area talking about this. So there's other algorithms available. There's the CART, SHADE, and Mars algorithms, and I won't go into details. The CART is classification and regression tree. The SHADE is a chi-square automatic interaction detector, and Mars multivariate adaptive regression splines. So these are the type of thing you may run into. But at least with what I've mentioned here, that gives you an idea that you want an algorithm that uses at least a C4.5 algorithm, and then depending on what you're doing, you may have to do a little bit of research to see if it would make more sense to use one of these other algorithms. And it could be just a matter of, if you have multiple implementations that uses these different algorithms, you could actually try creating a model and see how the model performs using these algorithms before you make a decision. So these, again, the idea is to think that decision tree, there's more than one implementation, so you can't just say, oh yes, I have a decision tree in this product, let's do it, let's use it. You have to go a little further to find out what's under the cover. The other thing you may hear about is something called ensembles. And so what that is, it's actually related to decision trees, because often under the cover it uses multiple decision trees. And let me go over just a few of those very quickly. The first one I want to talk about is random forest. So the random forest basically uses multiple decision trees instead of create one big one over all your attributes. In the example I had earlier, I had something like 15 attributes, I believe, 14, 15 attributes. And so that's not a very large number, and some of them were not significant, so that's pretty small. But in real life, you may end up with several dozen attributes. And the problem with one big decision tree is that the precision becomes less, the decision tree becomes a lot less reliable when it has to go over a large number of attributes. So the way to handle that is to use an ensembles of trees that will randomly split the attributes over multiple decision trees, And then there's another algorithm on top of all this that will average, do some calculation to average the answers that it gets out of the trees to get the final answer. And that's been proven that it provides a much better precision in your algorithm. Of course, by doing this, that becomes a little bit more opaque in terms of finding out why the decision was made. But that's, again, something to consider. You want to use decision trees, depending on how many attributes. You want to get to use, let's say, random forest. The last one I want to talk about is boosted trees, and that ties into what I was mentioning earlier about the support for boosting and the C5 algorithm. And that's yet another approach that uses what's called a gradient boosting. And that's usually typically used in trees that are based on the CART algorithm. But the idea here is for people that think about gradient descent, that gives you a bit of an idea. It's basically figuring out the steps to get to a better precision, and you use small steps so you don't overlook, let's say, the best possible decision. And so that's another one that can be interesting to use. You hear about algorithms like implementation like XGBoost, for example. And so that's yet another thing that is related to decision trees part of the ensembles that you want to look at when you want to make these decisions for either multiple decisions, either or churn, like churn analysis where it's a binary decision. So that pretty much completes the overview of decision trees I wanted to give you. So hopefully with this, you have a better understanding, well, first, that why decision trees are part of machine learning, because it's not just doing a manual if then else, it's really deciding over the patterns that are found in the data to get to the answer. Hopefully, again, you understand what the decision tree does, and that there are multiple algorithms under the cover that you will want to quickly investigate to find out what's being used in the product that you're using, may that be, again, Spark, sklearn, and SPSS and other products, to decide then if you have to actually create your model using multiple implementations to see which one is the best for you. And finally, the idea of going through ensembles, understanding that how ensembles, why it's called ensembles, because it's an ensemble of decision trees that are then averaged together to get to an answer. So for more information on data science, take a look at this URL. It's actually another URL that I have to point to the same thing, my YouTube channel. And please, if you're interested, go there and subscribe. For people that are interested in the Watson Studio product that I used a very small part of Watson Studio, the modeler flows. You can get more information on Watson Studio using the IBM DTE site, Digital Technical Engagement site, and I have the URL there that points directly to Watson Studio. And again, if you're interested into more of the IBM products, the DTE site includes many products. I believe it's over 80 different products that are being covered there. And you see the short URL here ibm.biz/DTE-live. And so with that, I've completed my presentation, and I'm ready to look at the questions.
Great. So we will open it up for questions. If you have a question, please let us know with the Q&A widget located on your screen. Okay, so it looks like we have a question regarding ensembles.
Let's see if I can open. I'm not sure. Oh, wow, multiple questions. Let's see. Okay, there was wow, multiple are coming in. Symbols need not necessarily be all decision trees. Could be a decision tree in different algorithms. I'm not 100% sure about this. From what I've read, there was often, if not, there was always a mention of decision trees under the cover. But you're correct in the sense that there are different algorithms that are used on top of it to be able to then look at the different decision trees. So hopefully that answers your question. You said C5.0 is for commercial purpose. I believe you simply have to license the. It has a commercial license, so you have to license the product. And so when you look at something like SPSS, you see that in SPSS we have the C5.0 algorithm available. So the decision, the algorithm was they basically bought the rights to use the algorithm. So that's really the reason there. I don't think you would go out and simply license the C5 algorithm on its own for yourself. Makes a lot more sense to use implementations that are there. Let's see, next one. Next one here. Can you provide an example of when to use random forest versus boosted trees? I'm not sure if you can say. Well, I don't really. I don't know what are the attributes, the characteristics of data that would make it better to use one or the other. And so that I believe that at this point, my best answer at this point is really to say, well, you'll have to try it on your data. And these algorithms are usually available in multiple implementations. Let's see. Are there recommendations on what type of data is best for decision trees? In general, decision trees seem to be better with, looking at the progression of the algorithms, the decision tree algorithms were better with categorical type data as opposed to continuous type data. But this type of continuous data has been supported, and depending on which algorithm implementation you use, you'll get a better result. Let's say if you use continuous data, that's where the CART algorithm classification and regression tree would make sense to use too. But as I said, in the C5, there's some capabilities added there. So I think the decision there would be more in terms of deciding if the answer you're looking for is categorical or continuous, and if the data that you're using is categorical and continuous, and you may want to use different algorithms for that. One thing I want to mention is this is just one approach to machine learning using decision trees. That doesn't mean that this is the only algorithm you can use. There are many other algorithms, and I'll put together additional webcasts in the future to cover other things. But again, it's not because you have a decision tree that it applies to everything that you do in machine learning. Okay, let's see what else. For an individual looking to try and test Watson Studio, what is the cost? Well, Watson Studio actually, you can go on the data platform.ibm.com site and create a free account. So what happens is you create that free account and you get so many credits per month, and when you pass that limit, then your account basically stops working until next month. So you can start using Watson Studio for free today just by going and creating a free account, and you can start using it. And what I showed here using decision trees, the modeler flow in SPSS, is actually available through the free accounts for any testing. If you go to the Bitesized Data Science site, a lot of the videos, the ones that show code, will actually include in the description a URL to get that free account, and has access to all the notebooks that I use in my examples in there. But yeah, so basically IBM Watson Studio Cloud is available for free for a certain amount of resources per month. And you can use also a lot of the Watson services that are available have a free implementation, which means that you have limited resources again, but you can take advantage of all of that. Is this going to be uploaded, published somewhere? I missed some parts of this presentation. Yes, this will be published on the community.ibm.com site. Ina mentioned that it will be done by tomorrow, I believe. She can confirm that. Yes, Ina?
Yes, I was just confirming this presentation will be available within the community by tomorrow.
Okay, great. How are partitions other than binary work? How that split happens? Again, the idea is that we're using a supervised learning algorithm. That supervised learning algorithm has an answer. In my case, in my example, it was binary, true or false. But if you had multiple values in there, that means that you have a set of records to train your algorithm that has these different values, and it will go through the same principle. Instead of being just binary, it would go through multiple choices to see how to gain the most information for each decision, and get to a point where you can say with a high level of certainty that this customer or this person will be in this category or not. One thing to know, I didn't mention that, but you have to be careful, because in some implementation of decision trees, you can get into something called overfitting, which means that using the data you use to train, you'll get a model that could be very, very highly accurate, even 100% accurate. But then when you use data that was not part of the training, you could have very bad decisions. So you have to kind of weigh that also. And the idea of using decision trees, that's one of the algorithms where you have to be careful. Actually, a lot of algorithms you have to be careful about that overfitting. Let's see. Last one here. You said, I reckon the decision trees are a simple form of machine learning. What if decision trees are not sufficient? How should one proceed if that's the case? If decision trees are not sufficient, in the context of this presentation, that's where the ensemble come in. The ensembles can kind of help in making it better, but basically there are many other algorithms, and hopefully I'll be able to do additional webcasts to cover several of these other algorithms that can be used to provide a similar answers to a similar data set that could make more sense. And basically, at this point, if this is the only algorithm you heard about, basically you have a hammer and everything looks like a nail, right? You know, the old expression. In our case here, hopefully over time we'll cover. I'll do additional webcasts to cover other algorithms that then would allow you to make decisions. If you go to that Bitesized Data Science channel, actually in the first few videos, I talk about several of the algorithms there, and these are like 5-minute videos, so that goes pretty quick. That could give you an idea of the other types of algorithms available. And I just started this week, posted about neural networks. And so that would be another approach. I've tried actually and that will be the one I post next week, an example of neural network to do similar type work, and that could be the answer, moving on to either a different algorithm, part of the more standard, what they call often shallow learning, the algorithms, or go into the neural network that's part of the deep learning type algorithms. Okay, I think I'm way over time. I'm going to go through. There was one last question, and that will be it. Otherwise, I'll have to answer that on the IBM community. There's more. I'll have to answer the others on the community.
Right. So any other questions, please feel free to go to the community to the data science forum. You can ask your questions there, and Jacques will respond to you via the community. But we are running over our time, so I just want to thank everyone for attending today's webcast. As said before, please just feel free to continue any discussions in the community by clicking on the link located on the left-hand side of your screen. And again, the recording and the slides will be available tomorrow in the on-demand webcast archives, and you'll receive a follow-up email with the link. So this concludes today's event. Thank you, everyone, and have a fantastic day.